Hi, I'm Dave Alwell, your instructor for SE3321. This is the first lab for the course. There are two objectives for the lab for today. One is to be able to log on to the Citrix server, and second is to use Excel to calculate four sets of probabilities for four distributions that we'll use in the course. The reason we do these labs by video and by lab worksheet is that I've found that doing them in class is very inefficient because not everybody works at the same pace. This allows you to play the video, pause it, work at your own pace, restart it, look at the lab sheet, and get things again on your own rhythm. If you're a fast worker, you can sail through it. If you're a little bit slower, you can take your time and get it right. And that makes life good for everybody. I'm going to begin by starting a browser here and by accessing a Citrix server. We've come a long way in the last 15 years in supporting software for our distance learning classes. We found that having a cloud server where the software runs on our end and you access it through a client application makes the support for software a lot easier, because all I have to worry about is you can run a Java applet on your machine. Everything else takes care at my end. So that means you can run this on your work computer, on your home computer. You can run it on a tablet. I've run it on believe it or not, on an iPad. I think you can even run it on a smartphone. All of which is good, and it makes the support package easier. But to do that, you got to be able to get to that. So that's what we're going to do this first part here, is to test your ability to get to the Citrix server. If you can do it, great, we'll stop. If not, send me an email message and I'll work with you individually on the side to get whatever issues are there resolved, so that when we need this server in about 2 weeks, it'll be there and I know it'll be working for everybody. Okay, so as the lab worksheet says, there's two addresses, one if you're on campus, one if you're not. I'm on campus, so I'm going to use the on-campus address. Also, notice that it's an HTTPS address. That's very important. You will not be able to access it without it. So I'm logging into voyager.ern.mbs.edu. Good. And here we have the Citrix site. It asks for MPS login in our 15-character MPS password, which I'll log in. It takes us a screen like this. The only folder we're really interested in is the Systems Engineering folder. If you come back and work with us on a full degree and have to do a capstone project or a thesis, you may be interested in the SharePoint site. If you're a residential student, you might be interested in student check-in. We don't care about any of that stuff right now. We're going to Systems Engineering folder, and it looks like I accidentally clicked on Minitab, which, okay, we'll click on Minitab, which is the application we'll be using in the course. Accept the degraded display, accept the government warning, and now it's loading onto my machine a client application. Asks me if I want to be able to read or write. I get the splash screen, and voila, here's Minitab. And this is not running on my computer, it's running on one of the servers, but I can work with it just as if it was running on my computer, which is really cool. All I want from you for this week is to get to this point. When you've done that, you can stop and declare victory. We'll go and log out of the Citrix server, and then we will log off of the website here and close the browser. That's all I want to be able to do for today. And I'm going to pause for a moment, and then we'll move on to the next part of the lab. All right, I'm back. Hopefully you've got a little video with you this time as well. All right, we're moving to the Excel portion of the lab. We have four different distributions we're going to be working with. The first one is a binomial distribution. You might recall that the binomial distribution has two parameters, n and p, and then we'll be looking at various possible values of the random variable, which I'll call x. The example in the worksheet says n is equal to 10 and p is equal to 0.6, and let's just choose a value of x equal to 1. I like to pull all the data out of formulas and place it in the spreadsheet where it can be viewed. I also like to name the cells. I'm going to name this cell N. I'm going to name this cell P. And I'm going to name this cell X. And name it up here, X. And what this does is it allows me to refer to the contents of these cells by these labels instead of by B2 or C2 or whatever, which is much easier. So this is what we're doing in A, B, and C. Now we're going to move to labeling the calculations. The probability mass function is the probability that X equals X, and the the cumulative distribution function is a probability that it's less than or equal to X. Okay? To get these, the function I call is binom dist, which is a standard Excel function. So most, but not all, of the distributions we're going to use in the course have these standard Excel functions. They all tend to end in .dist, and it's either the full name of the distribution or an abbreviation. So this has several arguments to the function: the number of successes, which is 1, the number of trials, which is 10, or n, the probability of success, which is their value p, and then a switch, 0 or 1, for whether or not we want the probability mass function or the cumulative distribution function. Here we want the probability mass function, so we put in a 0. Good. Let me pause for a moment. I'm back. So the value we get is 0.0015726 or to 3 significant digits, 0.00157. We'll try to report things to 3 significant digits as we go through here. To get the cumulative distribution function, I copy the formula down again, and I just change the 0 to a 1, and now I have the probability that I am less than or equal to 1 for my observed values. Okay, there's my formula. Oops. And of course, the advantage of this is I can just change this to a 2 and everything ripples, or a 3, or a 4, or a 3, or a 6, or an 8, for example. And all the calculations ripple without me having to type the formulas. Plus, by looking at the values here, I know which set of formulas I've calculated this for. So that's the whole point of doing it this way. Okay, good. So I've already labeled this spreadsheet binomial. Let me move to the next spreadsheet. We'll label this one Poisson. And we're going to repeat the idea here for the Poisson distribution. So my parameters are lambda. My value is x. I already used x on the previous worksheet, so let me call this x2. Put my value for lambda to be 0.5 and my value for x2 to be 1. Okay, and similarly, probability that x equals x and the probability that x is less than or equal to x. So I have got to this far here on my spreadsheet. I'm also going to name this lambda. And I'm going to name this cell x2. I'm back. I had to do a little editing to the lab worksheet, which is a little bit different on the left as you see it now. Okay, so now I want to get my probability mass function for the Poisson distribution entered. So this is going to be similar to the binomial. I'll type in equal. I'll start to type Poisson, and I get a Poisson distribution listed. And so for my x value here is x2. My mean is lambda. Remember that lambda is the mean for the Poisson distribution, but not for the exponential distribution. And a 0 for my probability mass function here. and I get 0.303, which is the value I wanted. And to get my CDF cell, again, I drag down. I change the 0 to a 1. And I get my value for the cumulative distribution function, which is good. Now, sometimes I want to do other sorts of values. So for example, I might want to see the probability that I was bigger than a certain random variable. I'm sorry, the random variable is bigger than a certain value. Okay. Well, as it says in the lab, the values that are less than or equal to 1 and the values that are greater than 1 partition the value set. They're disjoint. Their union is the whole set of values so that the two probabilities sum to 1. In other words, to get this, it's equal to 1 minus the probability it's less than or equal to it. And I can, it helps if I put a minus sign there. Good grief, minus. And so I get the probability of the complement here, which is 0.902, which is what I said. And so this idea allows me to use the CDF, which finds intervals from minus infinity to a certain value, and use that to find different types of intervals. We'll see a little bit more of that as we go forward. Probabilities of different intervals. Okay, let's stop here. You may be wondering why I'm stopping and starting this. The reason is I inevitably make some screw up in these, and having done this about a dozen times to get to this point, I've started breaking it into smaller pieces where I can get one piece right, put it aside, and then I'll merge them together. So we're moving on now to the normal piece. I'm on part 6 of the lab workshop, which you can see here. So I'm going to label the worksheet here normal. The parameters for normal distribution are mu for the mean, SD for the standard deviation, and I'll put an X. I believe I'm up to 3 now for my values of X. And the example I'm working here are mean of 3, standard deviation of 1, and we're starting off with the initial value of X equal to 1. Okay. For continuous distributions, I'm not too worried about the probability density function. I really only use that if I'm trying to plot the normal distribution in Excel. For most of the probability calculations, I'll use the cumulative distribution function. So I'll start by calculating that out. Probability that X is less than or equal to X. And again, equals norm, and it pops up this norm distribution function, which has a similar syntax. To make my life easy, I'm going to name this cell mu. Again, name this cell SD. Again, and name this cell X_3. Okay, and now for my norm dist, I have my value of X, my mean, my standard deviation. I'm sorry, I missed it. My mean, my standard deviation, and 1 for the cumulative distribution function. All right, so I get that the probability that a normal random variable that has a mean of 3 and a standard deviation of 1, the probability that it's less than or equal to 1 is 0.0227, which should look familiar to you from probability statistics course. And that's good. That's what I wanted to do there. I want to do a second thing now. What if I wanted to know the probability that it was between 1 and, say, 4? So let me add a variable here, x4, and type a 4 here. The probability that x is less than or equal to x4 here now. Oops, x_4. This would be much better if I could type. And again, I'll name this cell X4. And I'll come down here and I'll copy this. And I'll change this to from an X3 to an X4. Okay, so the probability that I'm less than or equal to 4 is 84%. The probability that I'm less than or equal to 1 is 2%. So the probability I'm between 1 and 4 is the probability I'm less than or equal to 4 minus the probability I'm less than or equal to 1, and what remains is the interval I'm looking for. So the probability that 1 is less than or equal to x is less than or equal to 4. Here is going to be equal to this probability minus this probability, which is 81.8%. And that's a pretty good idea. This idea of using the difference of two cumulative distribution functions allows me to get the probability of any interval by taking the CDF at the right-hand endpoint and subtracting off the CDF at the left-hand endpoint. And that, in fact, is what we have listed here. All right, so that's it for the normal distribution. I'm going to gamble and go right into the exponential distribution. I get a new worksheet, which I will label exponential. I will zoom my sheet to 200% so you have a chance of seeing what I'm doing. And we will now do for the exponential. So exponential distribution also has a parameter lambda, which I'm going to call lambda 1 for this one. And it has an x, which I'm going to think I'm up to x5 now. Okay, and I need a cell for my probability that it's less than or equal to a certain value. Again, continuous distributions, I'm really only interested in the cumulative distribution function. My lambda 1 value is going to be 0.5. I guess I called it lambda A in the workshop. Let's be consistent. Worksheet. Okay. And I'll name this cell lambda A. And x5 we said was 1. We'll name this cell again x5, x_5. And now to find my exponential distribution probabilities, I add my exponential distribution function, exp, comes in, and again my value of x, my value of the parameter, and 1 because it's a cumulative distribution function, and I want the CDF. And the value I get is 0.39347, close enough for government work, and that's what I wanted to do here. So the advantage of setting up the spreadsheets before, is like I said, is I can reuse them easily when the parameters are not buried in the formulas explicitly listed. So if I want to make this an exponential 0.75, I'll put a 0.75 here, and I want to find the value, chance that it's less than 3, I can do that, and voila, I can do these calculations. So in particular, this is a good start for doing the homework. You should be able to modify this to do most of the questions that are in the homework. Not all, but most of the questions are homework, and you should find that this makes it a lot easier. So I would save that. All right, so this is the end of my lab. I think it's going to clock in at about 15 or 16 minutes of me talking, maybe 17. It'll take you longer to run through it because you'll have to stop and play it, but hopefully you'll find this is very useful. I'll be interested in your feedback when we talk about this in our second lesson. I'm Dave Alwell. This has been SE3321. Thanks for cooperating and joining me in the lab today.